Welcome to JavaScript, the hard part, callbacks and higher order functions. So even though it's called the hard parts, this is definitely kind of like the gateway hard parts to all the other hard parts. So if you are newer to JavaScript, no worries, there's going to be a lot to learn and we will all communicate empathetically regardless of skill level. All right, so we will go ahead and dive in. And we're going to talk about callbacks and higher order functions. So I think saying one of the most misunderstood concepts in JavaScript is maybe being a little dramatic, but it is something that is commonly misunderstood. But it's something that's really powerful about JavaScript and one of the unique things to JavaScript. So it enables really powerful functions that are already built into JavaScript. If you guys are familiar with map or filter or reduce, these only work because of callbacks and higher order functions. It makes our code easier to read, more declarative. And if you are aiming to get into the immersive, this is the backbone of the technical interview, and also a lot of job interviews you'll go on afterwards. So understanding this on a deeper level, like we're going to get pretty granular with it, is really helpful for understanding a lot of things in the JavaScript ecosystem. So as always, we're going to start with some JavaScript principles just to start us off. And if you're like, oh God, I already know all of this stuff, trust me, if we go through this and you really understand what's happening line by line in this code right now in the very beginning, it's going to make understanding callbacks and higher order functions so much easier to grasp in just 30 minutes or whenever we get to it. So we are going to go through this line by line. If you don't know, we have functions in JavaScript. They are just essentially in packages of instructions, bundles of instructions that we package together with a label and the function keyword. We also have the thread of execution. JavaScript is a single threaded language. That means that the computer reads it line by line. And our thread of execution goes in and out of whatever function or execution context it's in. We'll see that in a moment. We also have memory, just a place for us to store data, right? We usually we can also call it a variable environment, but it's really just a store of data where anything defined in the function is stored, or anything that's defined in the global execution context is stored. So let's go ahead and break this down. Julie, you want to start us off? What's happening on this first line of code? What's the first thing that happens when we run this code?
So we're declaring a variable called num, and we're assigning it the value of the number 3.
Absolutely. And what happens next?
And then we are declaring a function definition, and it's called multiply by 2, and it's assigned its function definition.
Yeah, so when we first hit that line, right, we just store this in memory as a function definition. Janny, what happens next?
So we store that on the function, then we input an argument. Wait, hold on. Sorry. In terms of scope, we would then declare the constant output.
Absolutely. And what do we assign the label output to? What value?
The function and an argument.
So when we have a function label or a function name, we have parentheses on the end of it. That's us invoking the function. So we're going to assign output to whatever the invocation of multiply by 2 with the argument num passed in evaluates to. So if we're invoking a function, what do we need?
An argument.
We don't always need an argument. In this case, we do need an argument. But whenever we invoke a function, right, does it store or do all its functionality in this outer global execution context, or does something else happen?
Sorry, can you repeat that?
Yeah. So when we invoke a function, does it all happen in the global execution context, or is there some other environment that opens up when we invoke a function?
Oh, it goes into the local.
Yeah, we need a local execution context, exactly. You were just doubting yourself. Yeah. So every time we invoke a function, we need a new execution context. So we'll write that out right here. We need multiply by 2. And like you said, we need an argument for this particular function. So it looks like right here, we're passing in num as the argument. If we check our global memory, num has the value 3. So we're going to pass 3 in. And then we'll draw our execution context. We also have the call stack, which is where we store all of our functions that are being called. So we need to push this function onto the call stack. Multiply by 2. And so that's on the call stack. We have our local execution context. Let's see, Beverly, what happens now?
Okay, you have your local execution context. So you will have to pair the argument with the parameter.
Absolutely. And where do we do that?
You would do that in the local memory within the local execution context.
That is correct. So here's our local memory. And we're going to pair our parameter with our argument. So our parameter, our placeholder, is input number. And we're going to assign it the value of whatever our argument was, which is 3. Beverly, you want to keep going? What happens next?
And then we're going to declare the variable result.
And what value do we give results?
And result would be the result of multiplying the input number times 2. So it would be 3 times 2, which is 6.
Awesome. Thank you for doing the math for us. So result equals 6. And let's see, Caitlin, what happens when we hit this line right here?
The keyword return places the output of result into the global memory.
Yeah, so the return keyword, it closes the execution context. It also returns whatever data it's returning out to wherever the function is called. So in this case, totally, it is the global execution context, and we do store the returned value in output. So then since we returned, right, we pop this off the call stack. This whole execution context in local memory goes away. And now output evaluates to 6. So Caitlin, why don't you keep going? What happens on the next line of code?
We're declaring, sorry, is it the last line?
Yeah, so that was my fault. I forgot to draw our little execution context arrow going into here. But when we return, the thread of execution exits the local execution context, goes back into wherever it was called. And this means this line is now complete.
Okay.
So
then we're declaring a new constant variable, new output, which will be the result of calling multiply by 2 with an argument of 10.
Totally. And if we're calling a function, what do we need?
An execution context?
Absolutely. So we need multiply by 2 with an argument of 10. We're going to create a new execution context. We're going to pop this, or push this rather, onto the call stack. 2, 10. And then every time we open up a new execution context, we always have local memory. And let's see, Laurent, what happens next?
Sorry, I was muted. So now we're going to call the, so we're going to declare another constant variable result, and we're going to assign the value of the input number, which at the time the argument that was passed was 10, and we're going to multiply that by 2, which equals 20.
Totally. The first thing, though, first is if we declare this variable result, this constant result, and we set the value to input number times 2, but then what's going to happen is our code is going to look in our local memory and it's not going to find input number. Then it's going to look in our global memory and it's not going to find the label input number. So first we have to match up our parameters to our arguments. So first we'll do input number equals 10. Then you're absolutely right. We declare that a constant variable result, which evaluates to the input number, which is 10 times 2, which equals 20. So results evaluates to 20. And then we return the result, which means new output now has the value 20. This is evaluates to 20. Our execution context goes away, almost, if I can erase it all. And then we pop this off the call stack and we finish running our code, and that's it. Questions on just sort of how functions work in JavaScript, or this basic setup of global memory, call stack, execution context? Can I get thumbs? Thumbs up means I'm good to go. Sideways means questions. Thumbs down, I have no idea what's going on. Thumbs up, thumbs up. All right, I think everybody has thumbs up. Cool. And I forgot to tell you guys earlier, if you come up with, if you have questions, feel free to shout them out or throw them in the chat. You know, if there's not too many of us, I don't really mind if you just shout it out when you have a question, but I'll also stop every now and then and just make sure. All right, so let's talk about functional programming. Functional programming is a programming paradigm, which is just kind of a fancy way of saying like a way of programming or an approach to programming that is focused entirely on functions, and especially pure functions. So a pure function is a function that has no side effects, which really just means that we're not going to alter our input directly. We're not going to alter any variables outside of our function scope. And instead, we're only going to have side effects or manipulate data or do something to data inside of the actual block of the function. This is really important when it comes to higher order functions, because higher order functions are the way that functional programming really works in JavaScript. And higher order functions, that sounds very like enlightened and powerful, and they are a really powerful tool, but essentially they're just functions that act a little bit differently than other functions. And they don't even really act differently. Any function could be a higher order function. It's just a matter of how we use them. So this allows us to have more readable code. It's a very valuable professional tool. Like I said earlier, map, filter, reduce, you'll use them all the time in professional coding. They will make your life way easier. So we'll get into it. So first, let's make a function 10 squared. Who wants to walk me through the syntax of what our function 10 squared would be? Sanaya, you want to walk us through it?
Sure.
Okay.
So first, we're going to declare a function titled 10 squared.
Okay.
The
You can keep
parameter.
going. I'll just do my best to keep up.
Okay, perfect. I just wanted to make sure I'm cognizant of your pace. Then the parameter that we put in it will be num.
So if we look here, we're going to create a function 10 squared. It's going to take no input. It's just going to return 10 times 10. So we don't have a parameter.
So then
I
we're
guess
just going to return.
Weirdly. Okay.
Then we are going to return, you can put parentheses after that, 10 multiplied by 10 with the semicolon after.
Beautiful. So this function, right, every time we call it, it's going to return 100. We could call it 1,000 times, and every single time invoking this function would evaluate to 100. So that's pretty cool. If we want to have a function that just always evaluates to 100, which seems a little silly, we could just probably write the number 100. What if we wanted to create a function that returns 9 squared? Shireen, what will we change to make this function return 9 squared?
We would just return 9 multiplied by 9 in the second line.
Yeah, and maybe we like change the name to 9 squared. And then instead of returning 100, it returns 81. And what do we think? Is this a valuable function? Right now we have a function that returns 100 every time we call it. And now we have another function that returns 81 every time we call it. Helpful? Yeah, no, not particularly, right? So what if I told you that we also need a function 8 squared? Don't worry, I'm not going to make you talk me through the syntax of 8 squared. This is supposed to be painful. It's supposed to be tedious. We are illustrating a point. Julie, what could we do so that we don't have to write a function for every single number that we want squared? Like if we wanted to find out what 125 squared was, and we also wanted to find out what 4 squared was, what could we do so we could use the same function?
Create a callback function.
Close. Let's see. Beverly, what could we add?
We could create a general function and just take a parameter or an input.
Absolutely.
Yes.
We can generalize the function. In coding, we have a principle which is called dry, which is don't repeat yourself. It is not helpful to write essentially the same functionality over and over again like we did with our 8 squared, 9 squared, 10 squared. It was doing the same exact functionality to every number that it came across, yet we were writing a separate function for each number. So that's the beauty of parameters. They essentially act as placeholders for the data that will be passed in. So we don't need to decide what data to run our functionality on until the function is actually called. Right? Higher order functions follow the same principle. They're going to essentially allow us to do this without having to decide what functionality we're going to run and what data we're going to run, which don't worry, we're going to get into it a little bit further, but super important concept. We generalize the function. Now we have this function square num, and this just acts as a placeholder. We can pass any number we want into it, and we will get its square. Okay, and now we just have one function that can do all of the things all of our other functions we're trying to do. So suppose we have a function copy array and multiply by 2. It does exactly what it says it does. And it looks like it's a function that creates an empty array, iterates through an array that's passed in as an argument, and creates a new array where each element of that array is multiplied by 2. So let's diagram that out. Let's see. Esma, what is the first line of code? What happens first when we run this code?
We declare a function named copy array and multiply by 2, and we store it as a function definition in the global memory.
This is maybe the longest function name of all time. So we are going to store a function definition in our global memory, copy array and multiply by 2. Awesome. Esma, what happens next?
After we go to the line where we declare a constant named myArray,
Okay.
and we store in the global memory with an array of 1, 2, and 3.
Awesome. Then what happens?
We declare another constant named result in the global memory, and we assign it to the return value of calling the function copy array and multiply by 2. So we open a new local execution context and a local memory.
Absolutely. Then what else do we need? So we open a new execution context. What else needs to happen when we call a function?
We need to push in the call stack.
Okay. Apologies for my very small myArray. We do need to push it to the call stack. I'm just going to call it copy array because I don't know how many times I can write copy array and multiply by 2. Copy array, it's on the call stack. What else do we need?
We are going to use myArray as an input for the parameter in the function. So
yeah, so if we look, we create a local memory. And I saw Beverly has a really great question, and we'll get to that in just a second, Beverly. In our local memory, we are going to store our argument with whatever our parameter label is. So our parameter is array. So array is assigned the value of myArray, which if we look in global memory is an array with the elements 1, 2, and 3. We will pause right here for just a moment. Beverly asked, what is the difference between a function declaration and a function definition? And essentially, Beverly, a function declaration is when we actually use this function keyword and we declare the function for the first time. The function definition is just all of this packaged up and stored to this label, and it can be accessed at any time. The function's only declared the very first time it's written. Other than that, whenever we reference the function, we're referencing its function definition. So if we were to like console log copy array and multiply by 2 without invoking it, it would like print out the function definition. Did that clear that up?
Yes.
Okay, cool. Yeah, I'm gonna erase all my scribbles because we need that in just a minute. So, Megan, what happens now? We have our local execution context set up. We have our local memory, our functions on the call stack. What happens?
We're going to create another variable in our local memory. It's going to have the label output, and we're going to set it equal to an empty array.
Absolutely. And what happens next?
So then we're going to create another variable with the label I, and I is going to be equal to 0.
Totally.
And then we're going to check that I is less than array.length. And the length of array is 3. So 0 is less than 3.
All right, so we'll
So we
say
can
0 less than 3. Megan
Yes.
is 0 less than 3. All right,
Yes.
cool. Awesome. And so we enter this for loop, right?
Yes.
Awesome. And what happens here?
So then we're going to push a new value into the array called output. So we're going to push into it the value array of 0, which is 1 times 2. So we're going to push 2 into the output array.
So array at index I, which is essentially I is 0, so it's array at index 0, and arrays in JavaScript are 0th index. So this first element is what we pass in. So essentially, we take out this array at index I, and we say 1 times 2, which is 2, and we're going to push that value to our output array. So now our output array has the value 2, and what happens next, Megan?
And then we're going to increment I by 1. So I is now 1.
So I is now 1. Awesome. Let's see. Jenny, what happens next?
We're going to run through the for loop again with the new index and push the next value into the output array of I at 1, which is 2, times 2, which is 4.
Totally. So first we increment I to 1, and now I is 1. We check is 1 less than 3, which I'm pretty sure it is. Then we enter here and we check what's at the index 1 of the array, which is 2. And 2 times 2 is 4. So we push that value to our output array. Maxine, what happens next? Or Max, if you prefer to be called Max. Maybe? Maxine, if you're talking, I think you're muted.
Oh, sorry. My
No, it's okay.
Sorry, I couldn't hear the question.
Oh, no worries. What happens next? We just pushed array at index 1 times 2 to our output array, which evaluated to 4. And now what do we do?
Well, then it would go through the loop again, or it would check to see if I was still less than the array length.
Right, so we got to increment I first. So I is now equal to 2. And then we check, is 2 less than 3? I'm going to say yes. And then what happens once we get inside of our for loop?
Then it will push it again, so it will multiply the number by 2.
Yeah, so we're going to grab the value that's at array index 2, which is 3. And we already know from earlier, 3 times 2 is 6. So we are going to push 6 into our output array. And why don't you bring us home? What happens next?
Okay, so then it goes into the array and then it's going to check again. And because now I is the same amount as a array length, then it's not going to go through it, and then it's just going to output or return the output.
Right, and where is it going to return the output to?
The console.
So not necessarily the console. It's going to return it to where the function was called, which is this label result. So result now is going to have the value of an array with the values 2, 4, and 6. And since we returned, I'm going to pop this off the call stack. This execution context, this memory is no longer And we have reached the end of our code. Thumbs on how we're doing so far. We copied an array, we multiplied it by 2. Everyone feels good. Love it.
What do you mean by call stack?
So the call stack is how JavaScript keeps track of like what execution context it's in. So essentially this global execution context is always on here. Anytime we invoke a function, we push it to our call stack, and whenever it's done running, we pop it off.
Hey, Sarah, I had a
Yeah.
question. I popped it
Sure.
in the chat. Does push have its own execution context?
Push does have its own execution context. It is an array method. It is a function.
Okay.
We don't draw it out in these workshops just because it's like, you know, a little, not too under the hood, but it's like it always does the same thing every time. And all we need to know is that it adds a value to the end of the array. So
Yeah, okay.
yes, technically when we do push,
But technically it does.
it would,
Okay.
yeah, it would
Thank you.
be on here and then would close out. Mhm.
Okay, cool.
Yeah. Awesome. Okay, we'll move on. So we copied an array, we multiplied it by 2. Man, but what if I wanted to copy an array and divide it by 2? Right? So let's diagram this out. Yenna, what happens when we first run this code?
Okay, we'll declare a function named copy array and divide by 2.
These function names are killing me. Okay, divide by 2. And
yeah, function as a function.
And then what do we do next, Yenna?
And then declare const my array and array inside number 1, 2, 3.
Great. And what happens next?
And then declare const result, which is copy array and divide by 2 and argument my array.
So are we invoking?
Yeah, invoking.
Cool. And what happens when we invoke a function, Yenna?
I forgot about the context.
Yes, so close. Execution context.
Yeah, execution context.
You had it. All right, so we got to open up a new execution context. So copy array and divide by 2. Awesome. And we know it takes the array 1, 2, 3 as our argument. Sanaya, what happens next?
So first we pair our parameter with our argument in the local memory.
Totally. I'm just going to push this onto the call stack really quick. Okay, so we open up our execution context. We need to pair our argument in our parameter. So our parameter is array and we're going to give it,
1, 2, 3.
Perfect. And then what happens next?
Then we move on to line 2, where we declare a constant variable called output in the local memory and set it equal to an empty array.
All right. You can keep going.
Okay, and then we move on to our for loop. So we first begin by declaring a variable I and setting that to 0 in the local memory. And then we begin to conduct our for loop. So at an index of 0, we check if 0 is less than the length of array, which is 3, and that is correct. So we move on to the body of the for loop.
Okay,
Then-
so we move on to the body of the for loop.
Then after that, we first dictate at array I, which is 0, the value is 1. And we divide that by 2, which gives us a value of 0.5, and push that into the output variable in our local memory.
Beautiful. So we have 0.5 in our output. Sadaf, what happens next?
I becomes 1.
Totally. And then what happens?
And then it goes back into the for loop to check. And it's
Is
I is
1
equal,
less than
yeah, if I is less than 3. And then it is, so it's going to push it to be, so it's going to check, it increments to 2. I goes, yeah, so it'll be 1 to 2. And then the index of 2 is 2.
So we haven't pushed whatever's at index of 1 yet. So we incremented I, we check to see if I is less than 3, then we enter our for loop, and we have to push to output whatever's at array index I, which in this case is 2, because it's at index 1, divided by 2, which is 1. So we push that to our output. Then we increment I to 2, and Sadaf, keep going. What happens next?
So then so I equals, it goes back to the for loop, which is I equals 2. And then it'll ask if it's 2 less than 3.
I think it is. What do you think?
Yeah, it is. And then it'll push it to, well, not push it, but like it'll check. This is the part where I get messed up, but like it's like the index is 2, but that's actually 3 in my array. So then it's 3 divided by 2.
Exactly. So arrays are 0 with index. So this is position 0, position 1, position 2. So we grab whatever's at array index 2, which is 3, and 3 divided by 2 is, help me out with the math.
I don't know. In decimal
1.5.
1.5.
Yeah. Yeah.
And then 1.5. Yeah, and then I equals 3 now.
And
then it checks.
And then we check. 3 less than 3?
No, so then it returns output.
Yeah, so we break out of the for loop, and then we return our output, which is this array right here. And we're going to return it to result. So result now evaluates to the array 0.5, 1, and 1.5. Then we've reached the end of our code. We pop this off the call stack. This execution context is over. And that's it. If you liked copy array and divide by 2, you're going to love our next function. What if we copied the array and added 3? You guys noticing a pattern? Does it seem like we might be breaking the dry principle, the don't repeat yourself principle? Is it painful to keep whiteboarding out these functions that essentially do the same thing but are slightly different? Yes, it is. For me anyway. I don't know, maybe you want to write all these functions, but there is a better way. Beverly, what can we do to not break the dry principle?
We could actually add another parameter. So we have the array. We could also have a parameter we take in, and yeah, the instructions.
Yeah. So this is, now we're getting to the good stuff. you can pass a function definition to another function in JavaScript. There are some languages where you can't do that. It would be wild to even think about it. In JavaScript, this is a core concept of functional programming. We can pass a function to another function so that we don't have to keep writing all these functions with different functionality. It's kind of the same thing as when we decided, you know what, we don't want to write a function for every number we want to square. Instead, we're going to give it a placeholder, a parameter, and that way we don't have to define what the data is when we define the function. Instead, the data can be defined when we run the function. And this is the same thing here. Now, we not only don't have to define our data when we define the function, we also don't have to define the functionality when we define our function, right? Instead, we get to decide that when we call it, when we invoke it, when we pass in this second argument, instructions. It's going to be a function definition, and it's going to change depending on what we pass in, right? So now we can use this function to generalize. Let's whiteboard it. Let's take it line by line. Clearly, I did not erase everything from the last time I wrote copy, array, and manipulate. Let's see. Shireen, what happens first?
So we declare a function with the label copy, array, and multiply in the global memory and set it equal to the function definition.
Right, so copy, array, and manipulate. And we set it equal to a function definition. Lovely. What happens next, Shireen?
And then we go down and also declare a function with the label multiply by 2 and set it equal to a function definition.
Absolutely. And what happens now?
And then we declare cons with the label result. And well, I would say so far it's uninitialized, but
Absolutely.
it will be returning back whatever we will invoke from the copy, array, and manipulate function.
So we're invoking copy, array, and manipulate, which means
we are creating a new execution context.
Absolutely. So copy, array, bear with me while I write all this, and manipulate. What are our arguments, Shireen?
The arguments are the array 1, 2, 3 and the callback function multiplied by 2.
All right. Shireen, thank you for saying callback function. The function that we pass in as an argument to another function is our callback function. The function that takes in the callback function is our higher order function. So in this instance, copy, array, and manipulate is our higher order function. Multiply by 2 is our callback. So we open up this execution context. We got to add copy array to our call stack. We need some local memory. And Julie, what happens now?
So we process the parameters of the higher order function. So I think it's, array is going to be assigned the value of an array with 1, 2, and 3. And then instruction is going to be assigned the function definition of multiply by 2.
Absolutely. So instructions is actually a function definition, right? Because our multiply by 2 is just a label. And we're saying whatever you find that this label multiply by 2, that's what we're going to store at instructions. So Julie, keep going. What happens next?
So then it looks like we declare another constant in local memory called output, and it is assigned an empty array. And then it looks like we're declaring a value I and assigning it to 0. And then we move into the for loop. So I is currently 0. 0 is less than the length of array, which is 3.
0 is less than 3. We're going to say yes.
Yes. So then we enter the body of the for loop. And then we'll push to the empty array called output the result of calling instructions on array at index 0. So do we open up another function level execution context?
We absolutely do. So what happens here is whatever this evaluates to, that's what we are going to push to output. So before we know what to push to output, I see a function definition with parens, which means we're invoking a function, which means we need another execution context. So we are now, I'm going to change colors. So we are now going to open up another execution context, instructions, which is really multiply by 2, with the value array at index I, which is 0, I is 0. Array at index 0 is the value 1 as an argument. So, Julie, you want to keep going? What happens now? We're in our new execution context. We have a new local memory. We have instructions on the call stack.
So then we will process these parameters for instructions. So input would be assigned 1, right? And then we will return input times 2. 2 times 1 is 2. So we return that value to the label output in copy array and manipulate.
Not to the label output. Well, yes,
sorry,
it does eventually get there, but no, yeah. But first, so our thread of execution, we return, right? So we return to back out to this execution context. We pop instructions off the call stack. We get rid of this. And essentially now output dot push, we're pushing 2 because that's what calling instructions with the argument array at index 0 evaluated to. So now output holds the value 2, and what do we do now? Let's see. Beverly, what do we do now?
We increment I, and so now I is going to be equal to 1.
Great.
And then
we check, right?
Check, yes. Is 1 less than 3? And the answer is yes.
All right, and then what do we do?
So now we are actually going to open up another execution context where we're assigning, passing in.
Great. So I was just drawing that so we can see where it returns out to. So we go into this execution context, instructions. And what's our argument for instructions, Beverly?
It's going to be array at 1, which is 2.
1, so that's 2. Our thread of execution moves into our new execution context, instructions. gets pushed onto the call stack. And what do we need when we get in instructions, Beverly?
We're going to need a local memory.
We sure are. That is the most crooked line I've ever driven. Okay, so, all right, so we need a local memory. Inside our local memory, what do we need to store?
We're going to pair, can you scroll up just a little bit? So we're going to pair the array, I believe array survive with input.
Yeah, so we're gonna pair 2, which is array at index I, with input equals 2, and then what happens?
So then we're going to return our input times 2, which is 4.
4. And so when we return, we are going to pop that off the call stack. The thread of execution is going to go back where the function was called, which we're still inside the local execution context of copy, array, and manipulate. We are going to push the evaluation of instructions with the argument 2, which is 4. So now output has the values 2 and 4. Thank you so much, Beverly. Let's see. Nisa, you want to take it from here?
Unmute. Okay. So where is it? Output push. So we're gonna check if I is less than 3.
So I is 2 now. So we'll check. Is 2 less than 3? I'm gonna say yes. What do you think? Okay.
Okay. So 2 is less than 3, and then we will run the instruction of 2. It's gonna pop into the call stack instruction. Take the argument of 2.
So we're now at index 2, which means we're actually, JavaScript arrays our 0th index. So actually we're going to invoke instructions with array at index I, which is actually 3.
Okay. Yeah, and we will create a brand new execution context. And we will assign the parameter input to 3.
Absolutely.
Okay, and we will return the input, the 3 times 2, which is 6. We will push the value to the output.
Exactly. So because we returned, right, we pop this off the call stack. This execution context disappears. So did my call stack line. That's okay. And then we're going to push what that evaluated to, which was 6, to our output array. We're done with the block of code inside our for loop. So we're going to increment 2 to 3. And then what happens?
And then 3 is not less than 3.
Right.
And yeah, so the loop is over. We will return the output value.
Awesome. And where are we returning output to?
To the global memory result.
Absolutely. So 2, 4, 6. And then because we returned, we pop copy array.
Yeah.
Yep. And then this whole execution context is gone.
Yes.
All right. Thumbs. I know that was like a lot all at once. Thumbs on that. How do we feel? Good. This means I have clarifications. This means I'm lost. See a thumbs up. Thumbs up. Thumbs up.
Hey,
See, we
Sarah,
have
I
a
have
chat.
a quick question as well.
Yeah.
So while we're running our for loop and we have result in our global memory, is that just empty, or is it set to null or undefined, or until we run the functions?
There's a little bit of debate about that. Some people say it's undefined, but we at Codesmith like to say it's uninitialized because it is defined. It's not going to hold, like undefined is a data type and it's not going to hold that value. It just has to wait for this function to evaluate before it can see what value it's going to hold. So uninitialized is the proper technical communication for that.
Got it. Okay, thanks.
Yeah, no problem. Any other questions? All right. So how is this possible? Right? It's kind of, at least if you come from other programming languages, passing a function to another function is just something you don't do. But in JavaScript, functions are first-class objects. So JavaScript is an object-oriented language, and pretty much everything in JavaScript is an object. But in JavaScript, functions are first-class objects. So because of that, they can coexist and they can be treated just like any other JavaScript object, right? We can assign variables to objects. We can assign them as properties to other objects. They can be passed as arguments into functions, and they can be returned as values from functions. So this is a really powerful thing, right? Like I said earlier, you can write a function and you don't have to define what the functionality is when you first write the function. Instead, you can leave a placeholder and let that functionality be defined when the actual function is called, which is our higher order function, which is our callback function in this example, Esma.
So the higher order function will be copy array and manipulate, and the callback will be instructions.
Absolutely.
And here will be multiplied by 2 when we call a function.
Any function that we pass into another function is a callback function. The function that takes other functions is higher order function. So if you think about map, filter, reduce, you have to pass a callback to all of those for them to do the functionality that you want. So this copy array and manipulate is pretty similar to map, if you're familiar with that, where if you invoke the map method on an array, it will do something, some piece of functionality to every single element in that array and return a new array of the result of doing that functionality to each element in the array. And that's essentially what we're doing here with copy array and manipulate. So this is powerful, right? Because this could be, we did it all in the context of numbers and some sort of mathematical functionality, but this could be an array of words. It could be an array, or I guess I should say strings. It could be an array of strings. It could be an array of objects. This instructions function could be so much more complicated than just returning, input times 2, right? We could be manipulating the data even more. We could be traversing objects inside of it. There are a lot of things that you can do, but it's all based on this core piece of functionality that you can pass a function to another function so that you can generalize your functions as much as possible, and they can be reused across your code, even if you want to do something different every time. Thumbs on that? Are you guys going to use all the higher order functions now?
I just have a question. This is,
yeah.
We have multiple callback functions, right? So it doesn't have to be, it could be 3, 4, 5, like however many you need to make the code.
Yeah.
Okay.
Totally. Yeah, you can totally have more than one callback. They are treated just like any other argument. Like you could have, 10 if you really wanted to. That seems a little excessive. Maybe there's a way that you could get that pared down, but you could have a whole array of callback functions that you pass into a function. It's just any function that you use inside of another function, essentially. That's passed in as an argument. And you guys are very on it tonight. Not a ton of questions, which is totally fine. It means you guys are really getting it. So our higher order function takes in the function. The function we pass in is our callback. We just went over that. So it's just a term to describe these functions, higher order functions. Any function that does it, we call that, but there's nothing really different about them except for that. If it happens to have an argument that is a function definition, it is a higher order function. But other than that, its functionality is just like a function. So callbacks and higher order functions are so useful. They help us have declarative readable code, right? We get to use the functions that are built into JavaScript, like map, filter, reduce. They're the most readable way to manipulate data. And also, if you're interested in Codesmith, we totally test callbacks and higher order functions on our technical interview. And they are also tested in just like pretty much every programming interview you do in your professional career. Also, callbacks are a core of asynchronous JavaScript, which we are not going to get into today, but we do have an awesome hard parts on async and promises, which just wouldn't even be possible without callback functions. So just know that even though if this today felt very basic, it gets more complicated more quickly, but understanding this core concept under the hood is what is going to allow for you to build on that and get those more complex concepts down. What's next? We have career workshops. If you have already gone through a boot camp, or you're self-taught, or if you're just ready to enter the job search, we have how to get hired as a software engineer. We also have JavaScript the hard parts. Obviously, you're at JavaScript the hard parts. We have callbacks and higher order functions, which we just did. We also have closure, recursion, classes and prototypes, or object-oriented programming, asynchronous JavaScript, iterators and generators, and we also have a hard parts on Node, which is the server-side runtime for JavaScript. CSX, sounds like you guys are all doing CSX, but keep at it. CSX is great. That's about it. I had a lot of fun with you guys. I love women-centered hard parts and workshops. They make my heart so happy to see you all here and so eager to learn. You guys all killed it with your technical communication, and thank you all for being so willing to participate when I called on you. That's what makes these workshops really possible, right? Otherwise, I'd just be talking at you for hours, which is not fun. And that's about it. My name's Sarah. I'm on the CSX Slack under Sarah Powers. My email is sarah@codesmith.io. Feel free to email me or send me a Slack if you have any questions. I love nothing more than geeking out about code. Be happy to chat with you guys more about it. And that's about it. Any other questions before we wrap up?
Yes. Sarah, I have a question.
Go for it. Sure.
I know already you talked about how functions are first class objects. And what are the classes I mean, what does that mean?
Yeah, that's a great question. So functions, essentially, there's like a lot of different kinds of objects in JavaScript. Not like a lot of different kinds, but just that there are a lot of different things that technically are all objects. So essentially, a first class object just means that it's an object that has all of the functionality or supports all of the operations that are allowed to a regular object. So let me go back to a page where we have like some code on it. So if I wanted to do a regular object, right, I would just do like const obj, and then some curly brackets, and then name Sarah. Okay, let's say then I'm further down in my code and I want to add a last name. I could just do like obj last name Powers. You can essentially do the same thing to a function. Like you could like add a property to it if you wanted to. I don't recommend that. There's really no reason why you would ever need to do that. But essentially, they are treated the same as any other object, and that's all that really means. And so that's why they can be passed as arguments into a function.
Okay. And there's other classes, right, too? Or just
there's not like it's like this is a first class object, this is a second class object. It's just to designate that functions are, even though we call them a function, they're technically a function object, and they are treated like any other object when JavaScript actually reads them and processes them. Does that clear it up a little bit?
Yeah. Thank you.
Okay, cool. Yeah. All right. Any other questions before we wrap up? All right, guys. Well, thank you so much for spending your Wednesday evening with me. Like I said, feel free to reach out if you have questions, you want to talk about code. I would love to geek out about code with you. I hope you all have a lovely night, and I hope to see you all soon. Bye, guys.